The least part.
Check the mixer. Is it on? Yes. Okay. Why won't you minimize? There you go. Alrighty. What is this? Number 10. 10. Ugh. That's ugly. Why did that happen? Number 10. Okay, so we have antiderivative of cosine natural log of x dx. And I admit this one's kind of hard to see what to do. Now, you could try to use the u substitution here, where u equals natural log of x. In fact, why don't we try it? U equals natural log of x. du is equal to 1 over x dx. Well, clearly the dx and the dx I know what to do with, but I don't have, there's nothing I can do with this. What do you do with this? What can you do with this? And the answer is nothing. There's no place to put it. So just a regular u substitution won't cut it. So let's start over again. Start over. That's the cosine of log x dx. And this time, instead of using a regular u substitution, I'm going to use voodoo. Thank you. Thank you all. All of us sneezing at the same time. Coughing. Coughing. Okay, so u is equal to the cosine of the natural log of x. dv is equal to dx. That takes care of everything. So du is equal to the derivative of cosine, which is negative sine, of the natural log of x, times the derivative of natural log of x, which is 1 over x, dx. That makes dv, and v is equal to x. Let's get it going. Integral of cosine log x dx, that's going to be equal to uv, which is the cosine of log x times x, minus antiderivative of x times negative sine of log x times 1 over x dx, which is really ugly looking. Let's try simplifying it. That's x times the cosine of log x. We have minus, minus. Let's make those both plus. So plus x times 1 over x cancels out. Oh, that's kind of nice. Oh, this is really close to the cosine of natural log of x. What would happen if I did it again? So let's make this sine of natural log of x dx. We'll say u is equal to sine of log x making du 1 over x sine of log x dx. Yeah, it would be cosine. And dv is equal to dx, making v equal to x. So, oh, look at me. Let's see, we have now the integral of cosine log x dx is equal to x cosine of log x plus sine of log x times x minus the integral of x 1 over x cosine of log x dx. Great. Let's simplify. Integral of cosine log x dx is equal to x cosine of log x plus x sine of log x minus integral of cosine log x dx. Add it over. You get 2 times integral of cosine log x dx. Factor out an x. There is that constant still. Divide by 2 and you're done. It's a pretty amazing antiderivative. I don't know when you're ever going to see the cosine of log x in your future studies. You may never ever see that function, which is why we're in math, because it doesn't matter.
Can you scroll a little up to the right?
Sure. Up to where?
The right, the green part.
That way?
Yeah, that's it.
Mm-hmm. I think 10 multiple choice. I don't remember if it's 1 or 2 free response. I have to look that up for you. Well, I think from 10 to 13 and then 18. Those are all free responsey. Okay? Alva? Good?
Yeah.
Okay. Yeah.
Will the free response be weighted like equally, even though it's way less problem?
If it's just 1, it won't be equal. It'll probably be either 70-30 or 60-40. Okay, what are we on? Are we on 11 now?
Yeah.
Okay, slope field. Nice. dy dx. If you can rinse it out and then hang it up on the mug tree. Mrs. Ferrier wants to go to Lens Crafters. And let's see, get our coordinate axes. Oh, there they are. We want that. We're going from -2 to +2. Is that right? So, Bye-bye. Thanks for washing. Oh boy. I knew I shouldn't have done that. That's not good. I feel like I could have just drawn them all out by now. Right? What happened? Alright, I'm just gonna draw them. Damn you, machine. Okay, so let's think about when is slope equal to 0? When x is equal to -1, right? When x equals -1, and when y, or if y is equal to 0. So let's see. Where is x equal to -1? Here. All of these. Also, when y is equal to 0, that's all of these. Okay. So let's see. Let's start this first one. In this first one, y is equal to 1, right? Excuse me. Thank you. So when y is equal to 1, then it's the same thing as the x coordinate plus 1. So what is -1 plus 1? Oh, -2 plus 1. It's -1, right? Here's 0 plus 1. Here's 2 plus 1. No, 1 plus 1, which is 2. Here's 2 plus 1, which is the slope of 3. Here, y is equal to -1. So it's the negative of x plus 1. -2 plus 1 is -1. Opposite of that is +1. 0 plus 1 is 1. The opposite of that is -1. 1 plus 1 is 2. The opposite of that is -2. This is 2 plus 1, which is 3. The opposite of that is -3. Okay. Here you're going to do the exact same thing, but now y is 2, so you're going to double all of these slopes here. Okay. So this was 1. No, so 2 times 1 is 2, so it's twice that slope. Here, the slope was -1. 2 times -1 is -2. This was -2 times 2 is -4. This is -3 times 2 is -6. so that's the slope field. Luckily, you're not going to be judged too much on whether your slopes are correct or not, but you should definitely be able to see the trend of getting more and more steep, getting more and more steep, getting more and more steep. So the trend should still be there. Any questions on part A? Okay. So, when is the slope negative? So, very important part of this one. Okay. When is the slope negative? Okay. Well, we have the slope equals x plus 1 times y. Two factors, right? This is a product of two factors. If one factor is positive and the other is negative, you will get a negative slope. Does everyone kind of get that? Negative times positive is negative?
Yes.
Okay. So what are the two factors? Factor 1, factor 2. Okay. So what's factor 1? It's x plus 1, right? Okay, so you know what I should do? Okay, so slope. If factor 1, if this is greater than 0, and factor 2 is y, if y is less than 0, the slope will be negative, right? The other thing, well, let's go ahead and simplify that. Wouldn't that mean x is greater than negative 1?
Yes.
How about this? What if this factor was negative? Wouldn't this factor have to be positive? That would make the slope negative. Let's solve that. Isn't that x less than negative 1? Okay, so that tells me that the slope is negative if either 1, x is greater than negative 1 and y is less than 0, or 2, x is less than negative 1 and y is greater than 0. Does that make sense?
Yes.
Okay. Note, you cannot just list coordinates. It's one of those things where every year someone just tries to list the coordinates and they're wrong every year. See? Euler's method. Euler's method. Let's get our table going. We have x and y. What's next?
Delta x.
Delta x. What's next? M.
M equals dy dx.
Delta y.
dy over dx.
M equals dy dx. Delta y. And then last is, which is equal to m times delta x. That's confusing, isn't it? And then we have x plus delta x, comma, y plus delta y. Okay. Where are we starting? 2, 2? 2, 2. 2, 2. And what's our delta x?
Negative 0.5.
Negative 0.05. Okay. So what's m?
6.
M is going to be 2 plus 1. Bye-bye. Times 2. Is equal to 6. That's dy dx. X plus 1 times y. Yeah? X plus 1 times y. Okay, and that means delta y is equal to negative 0.05 times 6. And this becomes 2, let's see, what is that? 2 plus that 1.95, comma, 1.7. All right, not done yet. Let's carry that to the next line. Okay, this is still negative 0.05. Now this slope is 1.95 plus 1 times 1.7, which equals 5.0515. Okay. This is going to be equal to negative 0.05 times 5.015. That's equal to that. So this is going to be 1.8, comma, 1.54492. That should be 1.9, yeah. Are we there yet? Oh my gosh, okay. Let's do it again. Okay, negative 0.05. This is going to be 2.9 times 1.4492. negative 0.05 times 4.2027 is going to be 1.85, comma, 1 point, that 1, no, I'm lost. 2, 239. Okay. I think that's good enough for now. And we're not there yet. Last time. Last one. So this is 2.85 times this monstrosity. That. Okay. Negative 0.05 times this monstrosity. That. And that gives us 1.8, comma, 1.0625. How'd we do? Yeah? So finally, f of 1.8 is approximately equal to 1.0625. My God. Mm-hmm.
We use the calculator for this part.
Well, it does say calculator in front of it.
So we use the programming method.
You will need to show all of your work.
Oh. Oh, no.
Yeah. If you just write down the answer on a free response, you get minimal, if any, points. And that's 11. Okay, so I think for 12 and 13, we're going to do those in class. We didn't do D?
We did D in class.
Did we do D in first period? We didn't? Okay. Let's do D now then. Okay. What do we have? Part D. I don't know why I'm green. Part D, we have dy dx equals x plus 1y. That means dy over y equals x plus 1 dx. Natural log of the absolute value of y is 1/2 x squared plus x plus constant. Let's check. Natural log of 4 equals 1/2 times 0 squared plus 0 plus c. Absolute value not necessary. So the natural log of y is equal to 1/2 x squared plus x plus c. E to the natural log of y equals e to the 1/2 x squared plus x times e to the c. Let me get us more room. and you're going to let a equals e to the c. So y is equal to a e to the 1/2 x squared plus x. Our initial condition is 0, 4. So 4 equals a e to the 0. Therefore, a equals 4. And y is equal to 4 e to the 1/2 x squared plus x. Damn. Okay? (12) and 13 we're going to do in class. So let's look at 14. We're so almost done, I could smell it. 4 more. Cotangent cubed of x over 2, cosecant squared of x over 2 dx. So the u substitution that you might want to try is x over 2, but that doesn't really help with any of these trig functions. What would help is noticing that the derivative of cotangent is cosecant squared. So that means you can say u is equal to cotangent of x over 2. du would then be equal to 1/2, sorry, that's cotangent, 1/2 of cosecant squared x over 2 dx.
So you did it negative.
Yeah, you're right, it's negative. You're going to notice that we have the cosecant squared, we have the dx, we don't have any of this business, so you're going to divide that out, and you'll get cosecant squared x over 2 dx is equal to negative 2 du. Adam?
Would it become u equals cotangent cubed of x squared?
No. You do not want to do that.
So we can leave the cube up there.
And the reason you don't want to do that is because this turns into u cubed
Okay.
times negative 2 du. That's equal to negative 2 integral of u to the 3rd power du, which is negative 2 times 1/4 u to the 4th power plus constant. And after you do your substitution, that becomes negative 2, no, negative 1/2 cotangent to the 4th power x over 2 plus constant. Okay? Generally speaking, you don't want the power to be part of u. (15) Antiderivative of x, natural log of x, dx. Okay. You could try u substitution. U is natural log of x. No, that's not really going to help anything, is it? Yeah. So let's do our ultraviolet voodoo. What should we set for u?
ln x.
X. Doesn't a substitution work here?
Does it?
Yeah, because the natural
Let's try it. What's u equal to?
natural log of x.
Good. So du is 1 over x dx. Good. Now what?
Then x du equals dx.
Okay. Now what?
Substitute.
What am I substituting?
Um,
Do I
u
keep the x?
ln x and what's it called? And
What do I do with this x?
oh, oops. Let's see.
It's not going to work, right?
Yeah.
It's not going to work. However, if we use ultraviolet voodoo, I think u should be natural log of x. That's part of Liate, right?
Yeah.
So du is 1 over x dx. dv would be x dx.
Yeah.
So v is 1/2 x squared. So then Liate makes this equal to log x 1/2 x squared minus integral of 1/2 x squared 1 over x dx. Okay, so simplify that. 1/2 x squared log x minus 1/2 of x dx. Last integration. I think we can factor out of 1/4 x squared. I forgot the x here, didn't I? Yeah, that's it. That's pretty cool. $16? This chapter review is always so long. 16 is antiderivative of secant squared x over the square root of tangent x dx. So again, I'm noticing that the derivative of tangent is secant squared. So that tells me that this will be a regular u substitution. If it's not, I'll figure it out quickly enough, right? I definitely don't want to start by using integral by parts. Oh, this is very nice. We have the dx, we have the secant squared. All of that's going to turn into du. And then that's just power rule. does it do that? So weird. Two more. How's your 17? I know this is the last one we're going to do, right? Integral of 1 over x squared e to the 2 over x.
I
Mm-hmm.
understand why it turns into 1
Oh. Sorry, let me back up. Negative 1/2 plus 1 is 1/2. You got it? Awesome. 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 Right, so this one seems kind of difficult, but I think the key here is to notice that this is 2 over x over here, and to rewrite this integral. That's key. Once you do that, hopefully you can see that the derivative of 2 over x is something over x squared. So it's just regular u substitution. U is equal to negative 2 over x. That makes du equal to positive 2 over x squared. Dx. Okay, let's see what we have here. We do have the x squared, we do have the dx. We don't need that 2. So 1 over x squared dx equals 1/2 du. Ready to box it up here. Okay, so that's equal to integral of e to the u times 1/2 du, which is 1/2 antiderivative of e to the u du. Hmm?
How did you get from d equals 2 over x by dx to 1 over x by dx equals?
I divided both sides by 2.
Oh, okay. You couldn't have left the 2 on the other side?
No, there's no 2 in my integrand.
Why did that first 1 over x squared just disappear?
It didn't.
Yeah, you cancel it out, but how did you cancel out if they're both in the denominator?
I didn't cancel that out from the denominator. I canceled out the entire thing. This entire thing is this entire thing here.
Oh, okay.
Yeah, Patrick.
Can you explain again why you chose negative 2 over x as your du?
That's one of the common patterns is when you have an exponential function, set the u equal to the power of the exponential function. That might be a good rule just to kind of go along with as you do these with a u substitution. If this was UV dV, if this was ultraviolet voodoo, it's a completely different method.
Oh,
But luckily we don't need ultraviolet voodoo.
that makes sense.
How
Pardon?
do you know it's better to switch that, like,
To switch which?
to put negative 2 over x instead of 1 over x squared?
Because I know that the derivative of 2 over x is negative 2 over x squared. I took a derivative real quick. And I saw that that derivative gives me an x squared into the denominator. Okay, antiderivative then, that's just 1/2 e to the u plus constant. This problem is pretty much finished. So that's equal to 1/2 e to the negative 2 over x
Let's see.
plus constant. Or 1 over 2 e to the 2x, 2 over x
Plus constant.
plus constant. And that's it. I'm sure we'll be looking at